Hello! This video is for Stat 110, Module 1, Part 1, and includes the deafness hearing example. Alright, let's go ahead and get started. Before selecting on your notes, you're going to want to make sure that you're logged into your Stats class account. Let me show you what happens if you are not. So you will see within the notes here, there are spots for you to answer questions. Okay, but there's not a button for you to submit those answers. And the reason there's not a button is because you're not logged in. So you're not going to be able to submit those answers unless you're logged in. So let's go back, log into your account. Enter the username and password for your account. Now when I click the notes, you'll notice that there is going to be a Submit My Notes button at the top and the bottom of the notes. Okay, so now that you're logged in, we can go ahead and start our first set of notes here. So the first example that we're going to look at is a malingering patient. By malingering, we mean that they are exaggerating or trying to fool the doctors and nurses about some condition. So what we have here is a 27-year-old male with a history of hospitalizations. His hospital records indicate that he was manipulative, exaggerated his symptoms to his advantage, and was generally disruptive. So all symptoms, the situation here is this individual claimed that he had hearing loss. So this is the type of hearing test that they asked this individual to take. They put this individual in front of a screen. It had two lights. It was either a red light or a blue light. And these lights were on for 2 seconds each. Now a sound was played with one of those lights. So sometimes maybe it was the red light that had the sound being played when it was on, or sometimes when the blue light was on, the sound was being played. And this was done randomly between these two lights. This individual just had to identify which light was on when the sound was being played. So it's an atypical hearing test. I went ahead and created a simulation that can be used to mimic that hearing test. So out here on our course website, you can see that there's a link for the hearing app. We can begin the simulation. Here the red light is on. And now the blue light is on. And we heard the sound being played with the blue light. If we did another trial, this time the sound was being played with the red light was on. Okay, now the nice thing about this hearing test or this simulation is that we can do this as a deaf person. So all I need to do to my computer is turn my sound off or put my speakers on mute, and now I would be running this simulation as a deaf person. So the red light was on and then the blue light was on. And a deaf person would have to make a guess between these two lights. And I guess the blue light was on when that sound was played. If we asked a deaf person to run another, I'm going to say blue light as my guess, and I was correct. And we could keep doing that. And in fact, this individual was asked to do this a total of 100 times, I think it was. For the sake of the notes, we're just going to do 20 repeated trials instead of 100 repeated trials. So there was another blue one. Okay, back at the notes then. Understanding the outcomes. So suppose an individual was asked to participate in the hearing evaluation experiment that we did just now, and a total number of 20 trials were done. So situation A here, number of times an individual was able to correctly associate the light with the playing of the sound. This situation A is where that individual got all of those correct and none of them incorrect. Okay? Situation B is where the individual got half of them correct and half of them incorrect. Okay, so what can we say? The first question here is, what can we say if an individual had outcomes that looked like situation A? In other words, they got all of them correctly identified. All, or at least most of those, correct. Situation B looks like they were kind of split down the middle, half and half here. So that is the second question. So go ahead and hit pause on the video and try to answer those two questions. Okay. Now, if an individual was able to get all of those correct, so that would be situation A here, number of times an individual was able to correctly associate when the light was being played. So if they were able to get all 20 of those correct, then I'm going to assume that they can hear. Okay, so if we take our speakers off of mute, I'm able to hear that the sound was being played with the red light there. So if I did that a total of 20 times, I should be able to identify each time when the sound was being played with the associated light. So if we get 20 out of 20 correct, what that's going to indicate is that individual can probably hear. Now, if they're in situation B, where it's kind of half and half here, then that's going to mimic a situation where somebody cannot hear. So that was the situation of the deaf. Now, a deaf person is not likely to get 0 correct because there's only 2 situations here. And they're going to guess correctly some of the time. So if I guess blue again, oh, I was wrong. It was red. But a deaf person only has 2 options here. So they're going to be able to get some of those correct. And in fact, a deaf person is going to be able to get about half of those correct and half of those incorrect. So what about situation C here? An individual that doesn't get any correct on this hearing test. Well, that's going to imply that the individual can actually hear what's going on, but they're falsifying that, or they're lying about their ability to hear. So if they're on the extreme left side of this, they can actually hear, and I'm going to indicate, or probably will indicate, that they're lying. So I should not have said all that because that is the answer to question number 3. So go ahead, hit pause on your video, and answer question 3. Okay, now statistical methods can be used to fight against insurance fraud in situations like this. It is necessary to determine whether or not the subject in this investigation is intentionally giving the wrong answers. In order to make a determination of this nature, we must first gain an understanding of what a likely outcome is and an unlikely outcome. So let's talk a little bit about modeling deaf outcomes. A simulation model can be constructed to mimic the outcomes of a deaf person. This simulation requires the identification of 2 pieces of information. The first is the number of trials that the individual is going to complete, which is 20 here, and also the likelihood, the chance, or the probability of obtaining a correct guess. So for our example, as I said, the number of trials is 20, and the chance of obtaining a correct response for a deaf person is 1 out of 2, or 50%. That information has just been put into this table here. Now, the expected outcome for the number of correct guesses for 20 trials, with each having a 1/2 chance of being correct, is 10. So the expected value here is 20, which is the number of trials, times 1/2, which is the probability or chance of being correct, is equal to 10. So the expected value here is going to be the most likely value for a deaf person. The expected value for a simulation model presented here with a one-half chance of being correct is going to be halfway across that number line. So right here at 10. Now, it is possible for a deaf person to get 11 correct, or maybe even 12 correct. Or even if they're a lucky guesser, maybe they could get 15 correct. They could also get 9 correct. It's very likely that they're going to get 9 correct if they're a deaf person. 8 correct is probably likely, but 0 correct is going to be unlikely. They're probably not going to get all of their guesses incorrect. A deaf person that's what I'm talking about there. Somebody that's lying is likely to get them all incorrect because they're trying to indicate that they cannot hear. So one of the most important aspects to providing a solution to this problem is an understanding of the inherent variation that exists in the outcomes from our model. In particular, there is inherent variation, or randomness, present in the number of correct responses over repeated trials. The amount of inherent variation depends on the model being used. So here I would expect me to have about 10 correct for a deaf person. They could go from 9 here up to 11. They could go from 8 up to 12. This amount of drift up and down here is the inherent variation, or the variation due to just randomness. Up here near the top of the pyramid, I don't have much inherent variation. Here the inherent variation goes from 8 up to 12. Down near the bottom of this pyramid, I have a lot of inherent variation. That inherent variation drifts all the way down to 2 and all the way up to 18. In order to understand the outcomes or likely outcomes from a deaf person, I need to understand how much inherent variation there is for deaf people. That's going to be an important aspect in trying to determine whether or not somebody looks like they are deaf, or if they fall outside of this region, which would indicate that they are lying or being deceitful in their responses. Okay, that does it for Module 1, Part 1. Thank you very much.